Hello, my beautiful computer science students. Welcome to another AP CSA lesson where I, Goldie, take you through Unit 2 using objects. Today's lesson is Lesson 3, where we are going to be calling void methods with parameters now. So our objective is to call non-static void methods with parameters. So void methods means that we're still not returning anything, we're still not returning data, but this time we are going to be working with some parameters. Now, defining parameters, we've seen parameters in constructors so far, but we can also have them in methods. Parameters are values that can be passed to a method, just like parameters are values passed to a constructor. Methods that accept parameters will show the data type and the variable name of the parameter that will be accepted. So it'll show the data type of what it accepts, and then it'll have a variable name for what that method will call that, that variable in its signature. Okay. When a method is called, the values for the parameter are passed to the method. So we have two things. We have a method call and then a method signature. So the method call is a statement that'll happen inside of whatever program you have, and then it'll call on the method, and the method signature is what defines the method. Okay? So that's what you'll see here in your notes. We have method call and method signature. Okay. Let's start with the method call. So the method call usually uses dot notation, but not always. Okay. When it does use dot notation, what comes before the dot is the object's reference variable. What object are you acting on? Okay. Next, after the dot is the method name. So this is the method that you are calling, and it's the same method name in the method signature. In parentheses, we could have open close parentheses. That is going to be a method with no parameters. But here in this example, we have two parameters separated by a comma. So we'll see in the method call we have the number 5. That's our first parameter. And that value is passed to the method signature. Now, since we passed it in an integer, that data type has to match, and it does. Right now it says int first, meaning that you are expecting an integer to be in that position, that first parameter location. And 5 is now going to be called first in the method itself. So anytime in that method you use the variable first, it's going to be the value 5. And then the second parameter, okay? The second parameter is a string, and you can see in the method signature that that's expected. It wants a string in that location, and then that is going to be called second. So anytime second is referenced in the method body, it's going to be referring to the word example. Okay, so that's a method call and a method signature. So let's look at some examples here. Off to the left, I have code for an animal class. Kind of similar to what we saw in the last lesson, but I made a few changes. So I have one instance variable called type. I have two different types of constructors. I have my default constructor and my parameter constructor. And then I have 3 methods. Okay? All 3 methods are void, void talk, void say name, void get info. But now each of those methods is going to have parameters. Okay, so let's look at what happens with the following code segments. And again, it says assume the animal object is created in a class other than animal. So you're assuming that these code segments off to the right here are in a class that is not animal. So first we have animal Milo equals new animal dolphin. So that means Milo is our reference, and a new animal is going to be created using the parameter constructor dolphin. Okay, so dolphin is the parameter constructor. Dolphin T is going to get the value dolphin, so that when you assign T into type, dolphin gets assigned to type, and there we go. Okay, so a new animal is created. when I go here to Milo.talk and then in parentheses 4, so that says Milo is going to call on the talk method. So I go to the talk method. Talk method expects an integer. So you can see here just a single integer and you pass it a single integer 4, which means that age is actually going to get the value of 4. So age equals 4. Okay, so now in the method itself, where it says system.out.print I am and then plus age, okay, so it's going to print off I am and then plus the value of age, which age is 4. So that line of code, Milo.talk and then in parentheses 4, it's going to print off I am 4. Okay, so that's using a parameter in your method. Notice how I didn't use anything with the type. Okay, Milo is a type dolphin, but I didn't call on any of that data. It's just in memory. Okay, so the next line of code, Milo.talk. Again, it's going to look for the talk method, but this time there's no parameter. So what happens? Well, talk is still expecting a parameter here, right? So talk int age, it's still expecting a parameter. So this is actually a compiler error. The compiler will complain before the program is run. The talk method is expecting an integer parameter, and if it doesn't get that, it's not going to run. Okay, so you're going to have your compiler error. Okay. Next, we have 2 lines of code. Animal Queenie equals new animal. She's a rat. So again, in memory, Queenie's our reference. Type is going to be rat. And then I have Queenie.sayName, and then in quotes I have queen. So that means we go to Queenie is going to call on the sayName method, string name. So this method expects a parameter that's going to be a string, and I do pass it a string. I pass it queen. So then that means that name is going to be equal to queen in this method, okay, when this method runs. Once this method is done running, name is not queen anymore. Okay. So system.out.print my name is plus name, it's going to print my name is queen. Because again, name had the value of queen because that's what was passed to that method. And again, Queenie's type is a rat, but we never used it in our code. Okay? That's just location and memory. Parameters can work separately from your instance variables. This last piece, okay, animal Gus equals new animal. So Gus is created with the default constructor. He's an unknown type. Okay, let's talk about this right here. Gus.getInfo 3, Gus Gus. Okay. So getInfo is the method name, and it expects 2 parameters: an integer first, string. Does it get that? Yes, it does. It passed a 3 first, and then a string second, okay? Which means that in this method, A is going to have the value of 3, and N is going to have the value of Gus Gus. Okay? Now, this method has to run. Okay? So we're still on this line in our program, in our main method, okay? But the getInfo has to run before we go back and rerun the rest of the code over here. So the first line that happens is talk. Talk A. Now talk with the parentheses A, that is a method call, but we don't have a reference, right? And we ran into this in the last lesson. When you have a method call but no dot notation, no reference, you are saying go to the talk method inside this class. So the talk method is going to be called right up here. I'm going to highlight it, and it's going to get the value of A. A is currently 3. So this is going to call on talk, and then here it's going to pass it a 3, which means age is 3. So when it prints off I am age, you'll see it's going to print off I am 3. Okay. So again, it's kind of like a little chain there that you got to follow. So that is the talk method. Now the reason it prints off 3, well, because we passed it 3, but if we were to reference any instance variables, remember that it's always the original calling object that uses it. So if inside talk I use any sort of type for my animal, since Gus was the original object that called it, I would have my type be unknown. Okay? But I didn't use type in here. So this talk method ran, it is good. So next we move on to system.println and then open close parentheses. So remember what that does. When we ran the talk, print meant the cursor got left at the end of that line. So now when we go here, the cursor is going to print to a new line. Okay, nothing actually gets printed off. It's just the cursor, oops, sorry, I meant to do my little eraser there. The cursor moves to the next line. So you'll see that sometimes for formatting issues when you want to print something to the console, it just prints off a new line. Okay. Then I got say name. Okay. So say name again is a method call. You're going to pass it n. N right now is Gus Gus. So Gus Gus gets passed to this parameter, and name is going to equal Gus Gus. So what gets printed, my name is, and then Gus Gus gets printed off. So what you'll see, that line of code right here that we've been working with, it prints off, I am 3, my name is Gus Gus. Okay. I am 3, my name is Gus Gus. That whole line. Okay. I've reached the end of my get info method, so I am done with this line of code now, the get info line. I'm going to move to the next line. Gus got .talk 5. It's getting a little crazy here. Gus.talk 5. So the talk method here is what I would go to, and it's expecting an integer. Do I give it an integer? No. I give it a string because it's in quotations. I give it a string. So what happens? Well, you'll actually get a compiler error with that line of code. Okay? The talk method is expecting an integer, and if it doesn't get an integer, it's going to have a compiler error. Okay? So that line of code is not valid. The next line, gus.getInfo Gussie, comma 4. Okay? So again, getInfo, this method expects an integer, comma string. But what I pass it is a string, comma integer. Okay? So I flip-flopped them. Okay? Now, is Java smart enough to figure that out? No. Computers are very literal, okay? And in this sense, you will get a compiler error because the getInfo method expects an integer first, comma string. And if you do it out of order, it's not smart enough to figure it out. Okay, you have to be very explicit. So that last line, gus.getInfo, Gussie, comma 4, is also a compiler error. Okay. So a couple things to remember from that example. Values provided as parameters need to correspond to the order and the type in the method signature. Okay. Otherwise, you will get a compiler error. The order and the type must be the same. And if you have a method call inside of another method, like we did with the getInfo, we had talk and say name inside of the getInfo. It uses that same reference call as the original method. Okay. All right. Our last topic for this lesson is going to be overloaded methods. Okay. Now, overloaded methods are when there are multiple methods with the same name but a different signature. Okay. Now, when we talk about a different signature, the compiler is able to choose the correct method based on the amount of parameters and their types. So overloaded methods have different parameter lists. They do not have different return types or variable names. Okay. So return types meaning if it was void versus an int or a variable names in your parameter list, it doesn't distinguish between those, just between the amount of parameters and their types. Okay. Here's an example to make that clear. Okay. This is a correct way to overload methods. Okay. All three methods appear in the same class. Let's assume it's an object creating class. Okay, right? So there's no keyword static. Public, void, all of these methods are called print area. Print area. Print area. print area. But notice how their method signatures are different. This accepts a single int, this accepts 2 integers, and then this accepts 2 doubles. Okay, so that parameter list is different, and this is a correct way to overload methods. So print area has the same method name for each of them, but different parameter lists. Okay, now we're going to look at a code segment that's going to show this in action here. Okay, so this is going to appear in a method in the same class as print area. Okay, so we're going to call on these from the same class, so we're not going to use a reference or an object name just to kind of make things simple here. Methods appear in the same class do not need a reference variable to run on, right? So we're assuming this isn't an object creating class, but we're going to call on them from that class, so we don't need an object reference right now. And in this code segment, we're going to talk about what is printed when each line of code runs. Okay, so here's our code segment. So we still have those 3 print area methods, and then under it we have a code segment. I define 4 numbers, num1, num2, num3, and num4. Okay, 5, 4, 2.5, 3.5. Okay. Now I'm going to run my print area methods. Okay, so what happens when I run print area and then in parentheses I have num1? Okay. Well, Java is smart enough to know, okay, if there's multiple methods called print area, let me choose the one that matches that parameter list. So in other words, I pass it num1. Num1 is an integer of 5. So I'm going to go, Java says I'm going to go to my methods, and I'm going to find the method that accepts a single integer. Okay. The single integer is this method right here. So Java says I choose that. Okay, it accepts a single integer. That's what I want. So x gets the value of 5, and then what gets printed is the result of 5 times 5, which is 25. So on the console, that line of code is going to print 25. Okay. This next line here, print area num1 comma num2. Okay. Again, you're passing it num1 and num2, which are 2 integers. So Java will say, okay, I'm going to go to the print area method that accepts 2 integers. Okay. The 2 integer one is this one right here. So x gets the value, since it's first, gets the value of num1, which is 5. Okay. Num2 is 4, so y gets the value of 4. Order is very important here in your parameter list. So when you print off, you're going to print off the result of 5 times 4, which on the console is going to be 20. Okay, and you can probably see where this last one is going. Print area num3 and num4, num3, num4, both are doubles. So it's going to go to the method that accepts 2 doubles. So print area 2.5 is going to be the value of x, and y gets the value of 3.5. Okay. The order is important there, and then it prints off the result of 2.5 times 3.5. Since that is multiplication between 2 doubles, your result is also a double, 8.75. Okay, that's the correct way to use overloaded methods. Now, could you have named all 3 of these methods something different? Absolutely. Okay. There was nothing preventing you from calling it print area 2, print area 3, and then you didn't have to use overloaded methods. But overloaded methods can be helpful, and we'll actually see that all the way in Unit 9. So the last thing we're going to talk about is incorrect ways to overload. Okay, so this is going to be our last slide here. So again, here's our 3 print areas. You are considering adding the following method signatures to the same class. Which of these are valid method overloading examples? So which ones would you be able to add and still be valid? Okay. So this first one says public void print area, and then you see it's different from the others because it says int z. Okay. Now this one said int x, right? They both accept a single integer. One is called x, one is called z. Okay. Otherwise, they're the exact same. Is this a valid method signature? No, it is invalid. Okay? There's already a method signature with a single integer parameter. Java does not distinguish between variable names. So just because we changed the variable name on that does not matter. It's still a single int, and Java already has a method called print area with a single int. So that is invalid. Okay. Our next one, public int print area into x. So we already have a print area into x. Okay. But what's different about this one is the return type. So this is saying that it's actually going to return an integer value as opposed to just being a void method. So is that a valid method signature? Because the methods are different. Okay, the method signatures are different. Is that the proper way to overload? No, invalid. There's already a method signature with a single integer parameter. Having different return types does not matter. Okay, Java does not distinguish between return types at all. So that is invalid. Okay. Here, we have void print area integer. Void print area integer. Okay, so single integer. So we already talked about how that variable name difference does not matter, but now I have a modifier difference. Okay, so between public and private. Okay. Will Java be okay with that? No. Java is not okay with a couple things here. So the compiler does not distinguish between those visibility modifiers. Just because one's public and one's private, but everything else is the same, it does not distinguish between there. Okay. What about the last one? Print area double W double P. Okay, it has two doubles, but we already have a method with two doubles. Okay, already have a method with two doubles. This is invalid. Okay. Does not distinguish between variable names, only types and number of variables. Okay. So all four of these would be invalid method overloading examples. Okay. But that is it for our lesson on calling void methods with parameters. Okay. That wraps up our lesson for today. Thank you so much for following along, and I will see you next time.